Good evening, everybody. We are a group of students from WPI conducting a research project. Our project is the Buildings of Venice. My name is Antoine Pham. I'm majoring in computer science and financial technologies.
I'm Marcus Gafka. I'm majoring in robotics and mechanical engineering.
I'm Virginia. I'm a BSMS in mechanical engineering.
I'm Will Reed. I'm a BSMS in chemical engineering.
So to start off, we're going to talk about the background and rationale behind our project. Next, we're going to talk about our methodology and fieldwork plan. Then we're going to talk about some challenges we faced and the results of our project. And finally, we're going to talk about some deliverables and recommendations for the future. So currently, the urban landscape of Venice is shifting. Venice is a small, dense city where every building serves a crucial role. There are 15,485 buildings in the historic city. Over the past decades, the growth of over-tourism has transformed housing use and local infrastructure. We see this in the shift of long-term residential units that are being repurposed into short-term rentals and tourist accommodations, such as hotels, Airbnbs, and shops. So why is tracking building use important? The first reason why it's important is because the resident population continues to decline as job opportunities shrink. In this diagram on the right, we see the population for the historical center, the mainland, and the islands surrounding the lagoon. The blue line indicates the population for the historical center. As we see, it starts at around 160,000, and over the next couple of decades, it declines under 50,000. Secondly, a focus on tourism over local needs reduces essential public services. We see a decline in hospitals and schools, which also in turn leads to a decline in the job opportunities for the local citizens here, disincentivizing them to stay on the island. By tracking how many buildings are still used as primary residences, this provides a measurable baseline. This baseline allows future teams and policymakers to assess progress and the trends. So the goal of our project was to track residential housing patterns. To do so, we had three main objectives. First was to combine spatial data, census records, and field observations into a single unified map. Secondly, to visualize how many buildings remain residential today. And third, to set a reproducible method for tracking future urban change. In the next section, we will talk about how we achieve these goals.
So now we're going to talk about our methodology and data sets behind our project. So the first couple data sets we used were the buildings of Venice and the addresses. So as you can see by these blue shapes here, they represent all the buildings. The building data gives us hundreds of fields, including city planning data, catasto data, which is about land registry, and volumetric data. And as you can see by these purple dashes, they're a little hard to see in this picture, but those represent all the addresses, and there are often multiple addresses per building. Next, we use the 2021 census data. So like the US, Italy redoes their census data every 10 years, so our most up-to-date data is from 2021. Of these fields, we use the ABI 21 field, which is the total number of residential units per census tract. The EDI 21 field is the number of residential buildings per census tract, and the POP 21 field is the residential population per tract. Next, we use water consumption data. So we have access to the locations of all residential and non-residential water meters. We know the water consumption for each unit, for each meter from 2020 to 2024. And we also know the type of tariff that that unit pays for water, whether it's residential or non-residential. And lastly, we know all the tourist accommodation locations taken from the City of Venice website. So this includes short-term rentals, hotels, and other tourist housing throughout the city. As you can see, there's a eye-opening number of tourist accommodations throughout the city. And we brought together this data through a unique alias system by geographic location. So there has been no other meaningful and unified code that represents each building. So as you can see from our example, our code has 4 parts. It includes the sestieri, the island code, and the census tract code, and also the building code within the island. And we were able to connect addresses and water meters to their respective buildings using this alias code.
So now to quickly summarize our methodology, we had 2 separate field plans, first of which was to validate data sets that we had in ArcGIS that Virginia talked about earlier. So going out in the field and seeing if hotels and short-term rentals exist where they exist on the ArcGIS databases, going out and viewing doorbells on buildings, counting them up, and this could give us an estimation on how many units might exist in a building, going out and taking photos of shutters, and this could indicate if they're open or closed. It might indicate if someone lives there or not. And then our second half of fieldwork was an estimation baseline. We wanted to go out and get measurements ourselves of buildings and floor counts so that we could put it towards an occupancy estimation. So now to get into some of the challenges we faced during our project and our results. So first, our daytime plan for fieldwork was to use a website called ArcGIS Survey 123. So with this website, you can make your own survey that fills out your own fields that you want to make. So for our example, buildings. And on the left, it shows our survey that we made where you can collect a building picture and then a building alias. Virginia shortly talked about this, where here's our maps that we would use when we're out in the field, and each building has a specific number that we would fill in for this building alias part, and then an island code. So these 2 maps have island codes Island Zach and Island Mello, and this is short for Island San Zacharia and Island Maloney. So you would click the drop-down menu and choose whichever island you were surveying. Then you would count the number of floors of a building, the number of doorbells, making sure to wrap around the entire building to get all of the units. And then you would analyze the shutters floor by floor to make sure that if they were open or closed, and then you could mark their condition as well. Overall, we were able to do 2 complete islands surveyed with this survey 123, and we did 110 buildings shown on the maps here. So now to get into some of the limitations we faced, this is a big reason for why we wanted to collect our own height data, because about 1/3 of the heights were errors in the ArcGIS database, some showing up extremely tall and some showing almost flat. So we couldn't use these for our estimation on occupancy because they were unreliable. So now to get into some classifications that Venice uses for buildings. On the left, we have a spreadsheet for all of the codes describing different buildings, and then an English description. So just to give 2 examples here, we have a Class A building, which is a pre-19th century building with single cell frontage, essentially meaning it's 1 bay wide, it's not very decorative on the outside, and it's just overall very narrow. And on the right, we have a Class BG building, which is a pre-19th century building with 2 cell frontage. It's 2 bays wide. It's much more decorative because it overall has much more room. So now to get into our nighttime plan. The reason this occurred at nighttime was because we were using a measuring device that was a laser, and it was only visible during the nighttime. So overall, we were able to measure 239 building heights, collecting floors and heights of 15 buildings for 13 of the most common classifications. So we were able to establish that estimation baseline for 13 different classifications. And on the right shows a map we would use in the field where they're color-coded by the classification and numbered so we can track them.
So now getting into the data that we aggregated after our nighttime field work that Will talked about. This is our floor versus height by architectural type of buildings. So basically on these graphs here, the number of floors is on the y-axis and the height of the building is on the x-axis. The left is the data from the VPC ArcGIS layer, and the right was our data from fieldwork. Basically, we're trying to draw a line of best fit for these different classifications of buildings. So given a new building with a known height, we can guess how many floors it is, which tends to be a stepping stone towards our unit and population estimation. So there's 31 different types of building classifications. The most common ones, we've represented the lines here. And then for the ones that weren't as common, we used an average floor height of 3.9 meters from our findings. To verify these estimates, we made these charts for both floors and units. On the left, we have number of buildings on the y-axis and our estimate minus our observed number of floors, which is something you can observe easily in the field by just counting the layers of windows. So the goal here is for as many of the buildings to be in the 0 bar, meaning there's no difference between the estimate and the observed number of floors. And you'll see that the data is not perfect, and you get like a bell curve kind of tapering out. Similarly with units, we're estimating the units with doorbells. So we have our units estimate minus the number of doorbells on a given building, and that'll give us a similar distribution, confirming that our estimate has an average of around 0 with a slight bell curve. We're measuring the accuracy of our estimation models with these statistical values. The last thing we took from our field work was unoccupied units. So we took closed shutters as a visual indicator of unoccupied units. As you can see in the pictures over here, when you walk around Venice, you tend to find some buildings with some shutters that are closed. The bottom one shows a building that may have an occupied unit and some unoccupied units. We found that in 68% of cases, when we went up to a building or a unit with 0 consumption, we also found that it had closed shutters, which kind of verified our intuition about what the closed shutters might mean. So with all of that context, we can finally get into the weeds of our occupancy estimation. So first, we would take a building, and we'd find its architectural building classification, as well as its height. We'd apply the correct linear regression height model to guess the number of floors of the building. Once we had an estimated floor count, we could then eliminate it if it's a fully non-residential building, for example, a hotel, a church, a museum, a government building. Once we removed all of those buildings, we can look at locally inside the building uninhabited units based on the water consumption data and remove those. And then with what's left, we can divide the units up based on the information we get from the census tract. We can do a similar thing with the population from the census tract, and then we'll arrive at a building occupancy estimation that we can map across all of Venice. So here's some of the visualizations we created from this data. On the left, we have the heights of the buildings that we went to and collected, and using the information that we got from that model, we were able to estimate the heights for all the buildings in the city and weed out kind of some of those bad data points that Will brought up earlier. Other 3D models we made with our data included trying to represent residential units in the city. So here's the building's data set extruded by the estimated residential height of the building, which we took to be the total height of the building times the percentage of the units in that building that are allocated for residential purposes. And then on top of this, we can stack kind of the tourist height of the building, and this will be the total height of the building times the percentage of the building's units that are used for non-residential purposes. And this way you can kind of see the full volume of a building and what aspects or what amounts of it may be used towards residential versus non-residential purposes.
And next, we did a similar process with vacant units across Venice. So the shapes of these buildings were extruded upwards by the fields that estimates the vacant height of the building. And this was calculated by taking the total height of the building and multiplying it by the percent of the building's units that we estimate to be vacant. So we believe this information is important for the public and for the city to be able to visualize where vacant units may be and potentially reallocate some of these units to residential use and improve residential housing availability. And we also created a residential population density map. As you can see by these blue buildings represent a less than average residential population density, and blue is above average. As you can see, and San Marco is predominantly red. This is most likely because of the tourist attractions and tourist accommodations within that sestieri. But other sestieres like Santa Croce and Cannaregio have more blue buildings, meaning those neighborhoods cater more towards the residential population.
Now we're going to talk about some of our deliverables and recommendations for the future.
So basically, from our project, we had some major deliverables that we were trying to achieve. The first of which was an updated data set on the buildings of Venice with the fields of each building well understood and cleaned out if they were unnecessary, and new fields added as we saw fit. We also created an estimation model using both our measured data from our fieldwork as well as GIS data that the VPC provided. And then lastly, we documented our processes and our models in a repository for researchers and future teams to understand and build off of what we've created.
So to finish up our project, we had 3 major recommendations. Our first one was for policymakers to use the building level occupancy estimates that we had to help strengthen data-driven housing policy. This can help refine the zoning policies, or as we saw, we can help reallocate units that are vacant and repurpose the houses or the units that we know that are already being used for short-term rentals and things like that to hopefully help repopulate Venice. The second thing that we recommended was for future research teams to continuously expand, refine, and validate the estimation system. This could be by validating the assumptions we made during our project or just implementing new data into our model as we get it. Finally, for our sponsors, our recommendation was to use the verified data sets and models to guide long-term housing interventions and public engagement, to continue to spread awareness about the problems that Venice faces, and to continue to spread knowledge and to gain that knowledge to help address these problems. Thank you.
Okay, thank you. So we're open for questions.
How did you get access to the tool that you used for your nighttime fieldwork?
Thanks to Professor Carrera right here. He was a key pivotal point in this project, and he provided us with that tool to help measure the heights. So thank you very much for that.
Other question? Oh,
Come avete concluso questo lavoro? Cosa avete capito? Meno case, meno abitanti e tanto turismo. Cosa porta questo alla città?
So the question was, what was your final conclusion about the use of the buildings and the balance between tourism and residents in this city, based on your data?
Well, I think a lot of it is like spatial, and it could be hard to draw like major conclusions about like a bunch of Venice, but we can definitely look at the maps and see patterns of, you know, there tends to be more residents in some areas, like Virginia mentioned, in like San Marcos, more touristy versus other districts maybe have more residents. But
Traduco, la conclusione è da trarre dai dati, ognuno trae, però adesso ci sono dati specifici edificio per edificio su che tipo di uso c'è dentro l'edificio, se è turistico, vuoto o residenziale, quindi dopo uno può fare le sue lucubrazioni al riguardo. Giovanni, aspetta.
Historical problem in Venice, it's elevators or not elevators. Of course, most of the city doesn't have elevators, but it makes a huge difference whether you can have a tourist rental or even if you want to sell or buy an apartment. Because everyone says third floor, fourth floor with elevator, nothing. You didn't check, there's no way to check whether on your maps also insert the elevators. And maybe, because that would be very function on the second theme that you see for people who want to invest in new buildings, that's the point, elevators.
So our field analysis could only be done by observing the outside of a building, so we didn't really have access to visually, is there an elevator in this building? So unfortunately, we're not able to keep track of elevators.
okay, one more question.
Yeah. I'm just curious if there's a possibility of cross-referencing the data that you've collected with ownership and rental records, because you see around the town, sometimes there are really big buildings that appear to be totally empty, and I always wonder, who owns that?
yeah, we definitely talked about getting access to some of those records to validate our data, but usually there's a paywall there, or something. So we didn't get that far, but we did definitely discuss verifying with some ownership records to see if our estimates were accurate, maybe picking a few places around the city just to see how close we got with our guesses.
Basically, the bottom line is you can get information like that from the Agenzia delle Entrate, but you have to pay, I think, €2, something like that, for each visura. So we did my own house, because if you own the house, it's free. So they estimated the number of floors and units in my house, and they came out correct. So that we had some verification along the way. But we also added inside the data the reference to the catasto, the mappale and particella. So you could, if you had the money, run a full blast sort of search through the archives. All we need is 15,000 times 30,000. 30,000 is not that bad. We could probably do it, right? Anybody want to donate for that?
Okay, let's thank the team one more time. And then we can have the